Right now, while your car sits in the parking lot, something is eating it alive. Underneath the paint, inside the wheel wells, along the bottom edges of every door panel, metal is being devoured. Millimeter by millimeter, day after day, in complete silence. It is called rust. And most Americans only discover it when the damage is already catastrophic. When the paint bubbles and cracks open to reveal orange decay underneath the surface. When the hole appears in the fender and daylight shines through your quarter panel. When the body shop mechanic crosses his arms and says, $2,000 per panel, or we cut it out and weld a new metal. The auto body shop industry in the United States generates more than $73 billion every single year. A significant chunk of that revenue comes from rust repair, a service that in 85% of cases can be performed by any person with $3 of product and 30 minutes of free time. The reason you never knew that is brutally simple. $3 in your driveway does not pay the rent on a body shop. This is the story of a liquid that the military perfected during the Second World War to protect warships, tanks, and firearms from corrosion. A chemical process proven across more than 80 years of military and industrial use around the world. A process that body shops apply every single day and then charge you $2,000 for the privilege of watching. And a technology the entire auto repair industry praise you never discover on your own. In 1869, a British inventor named William Alexander Ross filed a patent that would eventually change the future of metal protection forever. Ross discovered that phosphoric acid could react with iron to create a thin, stable phosphate layer on the surface of steel. That layer acted like invisible armor, shielding the metal underneath from moisture, oxygen, and corrosion. But the process was slow, inconsistent, and difficult to scale inside a factory. 37 years later, another British inventor named Thomas Watts Coslett refined the formula in his workshop in Birmingham, England. Coslett filed an improved patent in 1906 that made the phosphating process faster, more reliable, and applicable to larger surfaces. His breakthrough crossed the Atlantic Ocean and landed in the hands of an American company called the Parker Rust Proof Company. Clark Parker, the founder, acquired the patent rights and began experimenting in his family kitchen with phosphoric acid formulations. Picture that scene for a moment. A man in his kitchen stirring chemicals in a pot, trying to stop metal from decaying. The Parker Company improved the process further through the 1920s and 30s, filing patent after patent for faster and cheaper phosphating methods. Then, the Second World War arrived, and everything changed overnight. The United States military had a massive problem on its hands inside naval shipyards. Hundreds of warships were corroding at alarming rates in the salt water of the Pacific and Atlantic Oceans. Tanks rolling through the mud and rain of European battlefields were losing structural integrity to rust within months. Firearms issued to soldiers were seizing up in the humid jungles of the South Pacific Theater. The military needed a fast, cheap, and reliable way to protect metal from corrosion under the worst conditions on Earth. The Parker Rust Proof Company answered the call with a refined zinc phosphating process patented in 1941. The technique was called Parkerizing, and it became the standard anti-corrosion treatment for virtually every piece of American military equipment produced during the war. Millions of rifles, pistols, helmets, vehicle components, and ship fittings were Parkerized between 1942 and 1945. The process worked so well that it became permanent military doctrine, and it remains in use by armed forces around the world to this very day. Here is what that process does at the molecular level inside a laboratory. Phosphoric acid reacts with iron oxide, which is the chemical name for rust. It converts that unstable, porous, destructive orange compound into iron phosphate, a stable, dense, black compound that bonds tightly to the metal surface. The rust literally transforms into its own protective shield right before your eyes. The orange disappears, replaced by a hard, black coating that resists moisture, blocks oxygen, and stops further corrosion dead in its tracks. This is not experimental science. This is over 80 years of proven military chemistry. But here is what the body shop will never tell you when you walk through their front door. That exact same chemical reaction, the same phosphoric acid, the same molecular conversion is available to you right now in a bottle at Walmart for $347. This entire system of knowledge is not hidden because it is secret. It is hidden because it is unprofitable. Inside the complete vault are the Forbidden Firecraft Manual, the Lost Rations Cookbook that kept soldiers alive when supply lines collapsed, the off-grid blueprint systems that replaced thousands in equipment, and the 72-hour blackout checklist used in emergency planning but never released publicly. And now, the same rust repair protocol body shops charge $2,000 for can be done with under $20 of material from any hardware store. Right now, your car is under chemical attack. Automotive rust is an electrochemical reaction between iron, oxygen, and water. Normally, your paint slows this process, but two accelerators destroy that protection completely. The first is road salt. The United States spreads approximately 24 million metric tons of sodium chloride every winter. That is enough salt to stretch dump trucks in a line for over 8,000 miles. In 25 northern states known as the Salt Belt, this process repeats every year from November to April. Salt dissolves into water and turns every wet surface on your car into an active corrosion engine. Studies show vehicles in Minnesota corrode up to 5 times faster than identical vehicles in Arizona. That salt creeps into wheel wells, rocker panels, seams, and undercarriages where it never fully dries. It sits there, silently accelerating decay. Road salt alone causes nearly $5 billion in damage every year to vehicles and infrastructure. Governments continue using it because it costs $50 to $70 per ton, while safer alternatives like calcium magnesium acetate cost over $300 per ton. Your car becomes the sacrifice in a cost-saving equation. The second accelerator is physical damage. Every stone chip, scratch, or dent breaks your protective barrier. Once bare metal is exposed, rust begins instantly, and rust is self-feeding. It absorbs moisture, expands, and accelerates itself in a loop that never stops. There are 3 stages of rust. Stage 1 is surface rust, light orange or brown marks where metal is still structurally solid. Stage 2 is scale rust, where paint bubbles and metal starts flaking. Stage 3 is penetrating rust, where holes form and daylight passes through the body panel. Stage 1 and Stage 2 account for 85% of all rust repairs performed in body shops. These are the stages that cost you $1,000 to $2,000 per panel but require under $20 in materials to fix. The exact materials are simple. Rust-Oleum Rust Reformer, $4 to $8, Loctite Extend. Rust Neutralizer, $4 to $6, FTC, Rust Converter, $3 to $5. Sandpaper, $1, Primer, $4, Touch-Up Paint, $8, Clear Coat, $4. The chemistry is identical in every case. The difference is not the product. It is the price structure built around your lack of knowledge. There are over 280 million vehicles in the United States. The average car is 12.6 years old, well beyond factory corrosion protection limits. Around 150 million vehicles operate in salt belt conditions every winter. Yet the auto body industry still generates $73.9 billion annually. 2/3 of consumers report they do not trust auto repair pricing, and they are correct, because the system only works when you do not know. Step 1 is simple. Buy Rust Converter from any store. Step 2, wash the area completely. Step 3, sand loose rust with 80 to 120 grit paper. Step 4, apply Rust Converter and watch the chemical transformation happen as orange rust turns black iron phosphate. Step 5, apply a second coat after 24 hours. Step 6, add primer in thin layers. Step 7, apply color-matched paint. Step 8, seal with clear coat. Total cost, $15 to $27. Total time, about 2 hours. Limitations exist. Penetrating rust requires welding. Structural damage requires a mechanic. Cosmetic perfection requires professional paint booths. But for wheel wells, rocker panels, door edges, and undercarriage corrosion, this method stops damage completely. Manufacturers know this. Volkswagen and Audi use full galvanization. Tesla uses aluminum body panels that do not rust. Ford switched the F-150 to aluminum in 2015. But most other manufacturers use partial protection systems that fail within years. A rust-free car is a car that does not return for early replacement or repair. That is not engineering failure. That is economic design. Body shops know this chemistry every morning. They apply the same phosphoric acid reaction you can buy for $3 and charge you thousands for it. The only difference between you and them is information. Rust does not stop on its own. It only stops when you act early enough to stop it cheaply.